Welcome to the deep dive. Today we're diving straight into something that, well, sounds pretty technical, software architectural patterns.
Uh-huh.
But here's the thing. These aren't just, abstract plans for engineers. They're actually fundamental to how every app you use works. Or sometimes why it doesn't quite work right.
Exactly. Understanding them is surprisingly useful.
Yeah, it gives you this shortcut to understanding the digital world no matter your background. Our source today is a really insightful piece from the Amigos Code newsletter. It's called 7 Architectural Patterns You Must Know, written by Mama Samba Brahim and Nelson Jallo, published April 16th, 2025.
Good article.
Yeah, and our mission here is simple. Unpack these 7 patterns, cut through the jargon and show you why they matter. Okay, let's unpack this.
And that's the perfect way to think about it. These patterns are like the blueprints for software. Think about a house layout.
Yeah.
A studio apartment is fundamentally different from a big mansion, right? Same idea here. Each pattern dictates how the software is built, how its parts talk to each other. Getting these basics really helps you understand software behavior. It's sort of DNA.
Okay, so let's start the tour. We'll keep it simple, use some analogies, and really figure out why these choices matter. First up is monolithic architecture. People often call it the all-in-one classic.
Uh-huh.
Basically, everything, the interface, the business rules, how it gets data, it's all in one big code base.
One big chunk.
One deployment.
Yeah.
Sounds simple, right?
Yeah.
Almost
Yeah.
the default way you'd think of building something.
And it is simple to start with. That's the big plus, especially for, smaller apps or new projects.
Right.
But, and here's the catch, the hidden cost often shows up later. Think slower updates or bigger risks when you deploy changes.
Ah.
Remember that studio apartment idea? It's cozy, sure, but if you spill something in the kitchen, well, it affects the living area too.
Makes sense. You can't just change one little bit easily.
Exactly. Scaling just one part or updating something small can mean touching and potentially breaking the whole thing. Deployments get risky.
Okay, so that all-in-one approach can get messy as things grow. What's the next step then? How do people deal with those growing pains?
Well, that often leads to something like layered architecture or N-tier architecture, as it's sometimes called. It's a direct answer to the monoliths problems.
Okay.
This pattern, like the source says, is all about separation. You split the app into distinct layers.
The layers like?
You've got the presentation layer, what you see, the business layer, the rules and logic, the persistence layer managing the data storage, and then the database layer itself.
Gotcha.
And the golden rule is no mixing. Each layer has its job and they don't interfere.
So it's like that tidy lasagna analogy from the article.
Right.
Everything's stacked neatly.
Exactly like a lasagna. It's great for structure, great for teams. Different teams can work on different layers pretty independently.
That sounds much better for bigger projects.
It is. Much more manageable. The trade-off, though, sometimes performance. A request might have to hop through several layers.
Ah, wow.
And that extra communication can slow things down a bit compared to a monolith where everything's right there.
Right, okay. So from that neat stack, we kind of jumped to something quite different.
Mm-hmm.
Microservices architecture. The article called it squad goals.
Yeah, that's a good one. It's a total shift from the monolith.
How so?
Instead of one big application, you break everything down into lots of tiny independent services.
Tiny services.
Yeah, each one does just one thing really well. So you might have a service just for users, another just for payments, another for orders, all separate.
Wow, okay.
And what's fascinating is the flexibility this gives you, but it definitely comes with its own challenges.
What's the big advantage, though?
Scaling is the big one. If your payment service gets hammered with traffic, you just scale that one service. The others are unaffected.
Ah, I see. Independent scaling.
Exactly. And fixing bugs is easier, too. Fix one service, deploy just that one, less risk to the whole system.
But you said there were challenges.
Oh, yeah. The flip side is complexity. Managing all those tiny services, dozens, maybe hundreds, monitoring them, testing them together, it gets complicated fast.
Right.
You need really good tools and, honestly, great coordination. It's like managing that freelancer startup in the analogy. Everyone needs to be on the same page.
Makes sense. So how do all these little services talk to each other? Is it just chaos?
Good question. That brings us nicely to service-oriented architecture, or SOA. The article calls it the corporate cousin.
Okay. Why corporate?
Well, it's similar to microservices breaking things into services, but there's often a key difference in how they communicate. SOA frequently uses something called an enterprise service bus, an ESB.
An ESB.
Yeah, think of it like a central switchboard or maybe a highly organized corporate Slack channel for applications. It routes messages between services, sometimes translates between different formats.
So it's more centralized than microservices.
Often, yes. And the source touches on this, it's important. Microservices usually lean towards lighter communication, like REST APIs, web-based stuff. SOA often used older, maybe more rigid protocols like WS,
WS. So, yeah.
which actually made SOA pretty good for integrating older existing systems in big companies. You could connect lots of different things through this central ESB.
Sounds useful for big businesses then.
Very, especially with legacy systems. But the downside is that ESB itself, it can become a bottleneck. If that central switchboard gets overloaded or fails,
Everything stops talking.
pretty much, it's
Yep.
a potential single point of failure, which
Yeah.
you have to manage carefully.
That raises that question again. How do you avoid that central bottleneck if the ESB can be risky?
Well, that's where event-driven architecture comes in. The source calls it the party animal.
The party animal. Okay, I'm intrigued.
Yeah, because systems communicate differently here. They don't always call each other directly. Instead, they send out events and react to them.
Events, like
What?
notifications.
Kind of. You have producers that fire off events, say, new order placed. And you have consumers that listen for specific events they care about and react. In the middle, there's usually an event broker, like a post office, making sure events get delivered.
So the producer just shouts, order placed,
Yeah,
and doesn't care who's listening.
exactly. The inventory system might hear it and adjust stock. The billing system hears it and processes payment. The shipping system hears it and prepares the package. They all react independently.
That sounds incredibly flexible, especially for things happening in real time.
It's super powerful for that. Highly decoupled systems, very responsive, but
There's always a but.
there is. Debugging can be a real headache. If something goes wrong, tracing that chain reaction of events across multiple independent services.
Can be like finding a needle in a haystack.
Pretty much. It's like trying to figure out who started a rumor at that huge party. And, complex event-driven systems often bring in other concepts, too.
Yeah. Like what?
Things like CQRS, that's command query responsibility segregation, basically separating how you change data from how you read data. And event sourcing, where every single change is stored as an event, like an unchangeable log.
Wow. Okay. That sounds deep.
It adds power, but also complexity, especially around something called eventual consistency.
Eventual consistency.
Yeah, it means data across different services might not be perfectly in sync immediately after an event, but it will eventually become consistent, like ripples spreading out. It's a trade-off you manage.
Okay, that's a lot to think about with event-driven.
Mhm.
Now let's shift to one that web developers might know well. MVC, Model View Controller, the web developer's BFF.
Absolutely, a classic.
Can you break down those three parts quickly? Model View Controller.
Sure. The model is your data, basically, and
Yeah.
the rules around that data. The view is what the user actually sees and interacts with the UI.
Right.
And the controller is the traffic cop in the middle. It handles user input, talks to the model to get or update data, and then tells the view what to display.
Seems like a neat way to organize things.
It is. Its main job is separation of concerns. Keep the logic separate from the presentation. Makes things easier to build and maintain, especially for anything with a user interface.
What's the main advantage and any pitfalls to watch out for?
The big win is that code organization. Changes to the look, view, are less likely to break the business logic model, and vice versa. Very helpful. The common pitfall, sometimes the controller gets too big.
How so?
It starts doing too much logic, too much coordination. They call it a fat controller. Kind of defeats the purpose of keeping things separated. And actually, this brings up a really important point, something folks like Eric Azimi and Nabil mentioned in the comments on the original article.
Oh yeah. What's that?
While MVC is super useful, many see it more as a design pattern you'd use within a larger system, maybe for the UI part, rather than a full system-level architectural pattern.
That's a crucial difference. So it's not usually the blueprint for the whole building, just maybe the design of one room.
That's a great way to put it. It clarifies how these patterns actually get used in practice.
So does that mean you can use MVC inside another pattern? like inside a microservice.
Exactly. And that ties into Nabil's point perfectly. These patterns aren't always an either choice.
Ah,
You can absolutely use MVC to structure the code within a specific microservice that handles, say, user profiles. They aren't mutually exclusive. It's about layering the right tools.
that makes so much more sense. They're tools you can combine. Okay, fascinating.
Yeah.
Let's move to the last one. Master-slave architecture. The article calls it command and control. Sounds hierarchical.
It is quite hierarchical. You have one central master component.
The boss.
Right, it directs the work. Then you have multiple slave components that take orders from the master. Often they handle read requests or store copies of data.
Like a conductor in an orchestra.
Yeah, that's the analogy used. The master coordinates, the slaves execute in sync.
Yeah.
It's very common in database replication for ensuring data is available in multiple places.
So the main goal is making sure the system stays up and data isn't lost.
Precisely. Redundancy and high availability are the key benefits. If a slave component fails, others can hopefully take over its load. The system keeps running.
Seems smart. Any downsides?
The main headache is keeping everything synchronized, making sure all the slaves have the exact same data as the master, especially when data is being written or updated. That can get complicated. Data sync headaches, as the article puts it.
I can imagine.
And another important point here, again highlighted by Eric Azimi in the comments, the term master-slave itself, well, it's falling out of favor.
Oh, why is that?
It carries some, historical baggage. The industry is moving towards more neutral terms like leader-follower or primary replica.
Okay, that's good to know. Leader-follower.
Yeah. And modern systems often use more sophisticated ways to manage this, like distributed consensus algorithms, things called Raft or Paxos. These are complex but really robust ways to ensure all parts of a distributed system agree on state, even if parts fail. It's a bit beyond the basic pattern, but important context.
Okay, wow. So that's our tour of the 7 patterns. We've covered the basics, the pros, the cons, but it feels like there's more under the surface.
Absolutely. We've touched on some nuances, but diving into those comments and the real-world application, that's where it gets really interesting.
Right. The article asks, so which pattern should you use? And the answer is classic. It depends.
Always.
Which tells us these patterns aren't rigid rules, they're tools. You can mix them, match them, evolve them.
Exactly. And those comments we mentioned really add depth here. Eric Azimi's point about SOA versus microservices, for instance.
Yeah, you mentioned SOA often used older protocols, more coarse-grained services.
Right, whereas microservices tend towards finer-grained services, REST or gRPC, often more DevOps-friendly, maybe more loosely coupled in practice. It's a simplification in the original article, but a useful one to start.
And the point about master-slave terminology being outdated.
Yeah, using leader-follower, talking about replication or quorum-based consensus like Raft Paxos, that's the modern conversation. It's important context beyond the basic concept.
And the clarification that MVC is more of a design pattern for a UI layer, not a whole system architecture.
Crucial distinction. It changes how you think about applying it.
Plus, the mention of CQRS and event sourcing, adding complexity to event-driven systems, dealing with eventual consistency.
Right. It flags that EDA isn't just simple event passing when you get into real-world scale.
And finally, Nabil's point that you can use these patterns together, MVC within microservices, for example.
Yes. They're not always mutually exclusive choices. It really makes you question how we neatly categorize these things. They're flexible tools.
So the big takeaway from all these nuances seems to be flexibility is key. Good architects adapt.
That's the heart of it. The patterns are starting points, frameworks. The real skill lies in knowing when and how to apply them, combine them, even break them thoughtfully based on the specific problem you're solving.
So what does this all mean for you listening right now?
I think the source's final thought nails it. Don't marry the pattern.
Don't marry the pattern. I like that.
Yeah. They're tools in a toolbox, not a religion. Understanding when to use each tool, when to adapt, when maybe not to use a standard pattern, that's real architectural wisdom. It's about solving problems pragmatically.
And that's why getting even a basic grasp of these patterns is so valuable for you. The next time an app feels sluggish or you see a notification pop up instantly, you'll have a little insight into the why. You'll understand the invisible decisions, the trade-offs happening behind the scenes that shape your experience.
It demystifies things a bit.
Exactly. So here's a final thought to leave you with. If these architectural patterns are the hidden structures shaping your everyday apps, what other invisible design principles might be influencing your experiences online and maybe even offline without you even noticing?